Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to it later on. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we will try to get to as many questions as we can near the end of today's webinar. And also at the end of today's webinar, we are doing a drawing for three $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our three winners. Excuse me. Okay, with that, we'll go ahead and kick off today's webinar, which is Mastering DevOps with AI-Powered Change Risk Prediction. Our speaker today is Amit Shah, who is Director of Product Marketing at Numerify. Welcome, Amit. How are you? Thanks for joining me.
Hi. Oh, thank you. Thanks, Charlene.
Well, I'm going to go ahead and let you get to your presentation there.
All right, sounds great. So thanks again, Charlene. So as Charlene mentioned, my name is Amit Shah, and I lead product marketing here at Numerify. So in my past life, I've been an IT consultant, and I've had several roles ranging from development, release management, product management, and IT strategy. So in short, I've had most roles that you could ever have within IT. And I'm going to start us off first by introducing you to who Numerify is, since I'm sure many of you have not had an opportunity to hear from us in the past. So the way we like to introduce ourselves or define ourselves is through the value that our customers have realized by using our platform. And so Numerify helps IT leaders boost the performance of their operations by providing the analytics needed to support both strategic as well as tactical initiatives. And so here are some of the examples of the types of benefits that Numerify has helped customers realize. These are based on a study that Forrester conducted with 3 of our customers, and they represent the average composite experience of these customers, especially in turbulent and volatile times like these. You really need to be looking at solutions and initiatives that can give you a quick payback, so that you can concentrate on adding value to your business. And so if you're evaluating any kind of initiative or solution, I'd encourage you to look at that as being one of the most important factors. And the Numerify customers are able to achieve these benefits because of 3 unique parts of our offering. The first one is a robust cloud analytics platform that gives you, both the traditional business intelligence as well as artificial intelligence to answer both broad and deep questions. Secondly, purpose-built solutions that help you instantiate proven best practices in your initiatives, of which one is actually aptly named Change Risk Prediction. And the third is our customer-proven success playbook. And so we've done this many times at very sophisticated IT organizations like yours, and so we bring the benefits of lots of experience to the table. And so what could this mean for you in the context of change risk prediction? So even if you have a fairly low change failure rate, typically our customers have one of less than 2%, this chart is really meant to illustrate that it is still worthwhile for you to invest in making that change failure rate even lower. So even if you're starting at a pretty low change failure rate, if you reduced your change failure rate by 0.5 to 1%, you can see some pretty significant savings. And these benefits that you see here are estimated only from the perspective of preventing a major incident, and don't really take into account the benefits of prevention to business disruption. So how can we help you do this? You probably have one or more of these systems. Each one of these is best of breed. Now, however, this landscape comes with some pretty significant shortcomings from a data and analytics perspective. And the first one is that of breadth. These systems were not really meant to talk to one another. And if you're a DevOps professional, you're painfully aware of that. There's so many tools throughout the DevOps tool chain that you have to spend a lot of effort trying to get to talk to one another. And so the end result of that is the data is often in silos. So that means that answering questions that span multiple systems requires you to manually query, make sense of, and stitch together the data. And the second shortcoming is related to depth. And so even if you wanted to answer a question within a system, these systems were not really designed for analysis. So you might be able to get great predefined reports and KPIs. So sometimes in the case of some of the newer DevOps tools, not even that. But deeper analysis or follow-up questions are still going to require a great deal of effort. And so the usual approach we've seen our customers take prior to adopting someone like us is a manual analysis cobbled together with the brittle Excel spreadsheets or data lake queries, or often just leaving questions unanswered because by the time you get the answer to the question, you've really moved on as a team. And so that's where Numerify comes in. We help you get true analytical insight from one or all of your IT systems of record so that you can go beyond the limited reports that you can get from your systems of record. Focus instead on finding answers rather than spending days or weeks cobbling together data from various systems. And so an example of what you can do once you've brought data together from all these various systems is on the right. You can see the Product Owner 360 dashboard, which helps organizations transition from a project to a product-based approach, which is really pivotal to successful DevOps adoption. So this dashboard brings together multiple data sources. The data sources include data from APM or monitoring observability systems, an ITSM system, and software development. And as we're going to discuss shortly, correlating data from across planning and operations is critical to chain success. So, you're all pretty familiar with this, but why bother with DevOps at all? So most organizations embark on the DevOps journey because of the promise of benefits like these that allow teams to be more responsive to the needs of the business. At the same time, higher application reliability will result in lots of savings from less business disruption in the short run and lower run and support costs. However, faster innovation introduces the need for higher levels of monitoring and observability, not just for your applications and infrastructure in production, but also, and I think this is key, for the people, process, and technology upstream of the application. Gartner estimates that 80% of major incidents are change related, but they've also estimated, based on their experience, that about half of those are related to people and process failures, not just technical failures. And so today we're going to be focusing on how DevOps teams can begin to achieve change management nirvana through the first three benefits here, through comprehensive AI and BI techniques. So let me take a first look at what change management nirvana looks like. So one example comes from Facebook, which is one of the pioneers of the next generation of digital services. Facebook engineers generate a lot of code, with more than 1,000 code changes ready to deploy daily. And any disruption to the user experience can cost both Facebook and the advertisers that depend on Facebook a lot of money. At the same time, they need to be consistently rolling out new functionality and fixing issues as they crop up. So Facebook rolls out changes in a fairly conservative manner, using what is referred to as canary deployment. So bug fixes are rolled out 3 times a day, while new functionality is rolled out every few days. Every release first goes out to employees, If that goes well, the release then goes out to a small subset, i.e. 2% of users worldwide. And if there are no new issues found like errors or performance degradation, then the release is finally rolled out to the entire production user database. So as a recovering consultant, I'm going to have to say the obvious. It's not possible without high levels of automation and in testing and deployment to do this. And you also need high levels of trust in that automation. So, you're probably asking yourselves, if you haven't done so already in the past, is it really worth striving for this? And the answer to that is also going to be, it depends. Even as Facebook does cool things like this, they weren't really born this way. They evolved these capabilities over time. Releases used to be manually reviewed as recently as a few years ago. And the automation came in as the manual processes were unable to keep up with the pace of change. So one of the most commonly cited frameworks for the automation journey comes from none other than the U.S. Department of Transportation. So while most attention is focused on the fully autonomous vehicles of the future, most new vehicles today actually come with some levels of automation and safety features. These mostly fall into the decision support for humans category. Things like the blind spot warnings, lane keep assist, and brake warnings when you think you're about to crash into the vehicle in front of you. So from an IT and change analytics standpoint, if you've had to take two things away, I think it would be these. The first one is that these fully autonomous vehicles get into accidents primarily due to unanticipated errors made by something or someone else. That is, even the most sophisticated AI ML models can't yet match patterns that they have not been taught based on past experience. And the second one is that even lower levels of automation and decision support can add tremendous value. So I, for example, have avoided multiple fender benders as a result of proximity and brake warnings. So if you apply this framework to change management processes, it would look something like this. So traditional change acceptance and the ITIL change management processes would be a level 1, dependent on change requesters rating the riskiness of each change based on their personal experience and manual data analysis. Many organizations are here, and in our experience, even organizations that are moving towards a DevOps or have adopted DevOps. Using machine learning models to sift through ITSM data that has been entered by humans and then manually interpreting the data to remediate these risks would be level 2. Many of our customers have started their change management automation journey here. Using machine learning models, recommendations on next best action, for example, approve this change or do not improve until the number of alerts goes down to normal levels. So that would be level 3. Many customers progress here once they gain trust in the output of machine learning models. Automatically approving and implementing simple low-risk changes would be level 4. So this is dependent on automated change deployment. Automatically approving and implementing simple low-risk and medium-risk changes will be level 5. So this is dependent on automated change deployment, high levels of observability in applications of infrastructure, and automated remediation for simple issues. And finally, level 6 is the ultimate state of Nirvana with no ops. All changes are automatically deployed, and all issues are automatically remediated. I think we're unlikely to get here anytime soon. So besides automating change deployments, what makes it hard to achieve higher levels of automation is the fact that the data that can predict whether or not a change is risky sits in different processes and system silos, both upstream in the development process, and downstream in the impact of the change. Now, for example, how the change was developed can help predict how risky the change is to deploy. This could include factors like the code quality. Now, are there known pre-production defects? Is there sufficient automated test coverage? Now, how effective are your test scripts or build? How often did the developer check in and integrate his or her code? Are build scripts for this module automated? Were there errors in the build? And another example would be risk factors in how the change was deployed. Which configuration items the change is being deployed to, and sometimes who's deploying the change. Now, another example would be, have similar changes caused performance degradation, as measured by observability systems, or user-reported incidents, as you would observe in your ITSM systems, and what was the root cause of these change failures? There's so many permutations and combinations of all of these factors. Which ones predict a risky change? And once you identified a risky change, how can you mitigate that risk? So a machine learning approach to change success can help you sift through these permutations and combinations of data, correlating across hundreds of fields and change incident CMDB systems on the ITIL side, as well as upstream development systems and downstream APM systems. And so machine learning models can help you identify not only which fields predict change risk, but also which combinations of those fields, when taken together, predict risk, even when individual fields don't. And we're going to be walking through examples of these in the upcoming demo. So with the results of these models, you can achieve two things. First, you can mitigate the risk of an individual change. So you can predict not only which changes are risky, but why they are risky, so that you can mitigate these risks. For example, a change could be flagged as risky because changes requested by a particular group have a high failure rate when changes are applied to a specific application deployed on a particular server, and then the change does not require a downtime. Mitigation steps for this type of risky change could include developing a rollback procedure, having the right SMEs on call when the change is deployed, and deploying the change after business hours. And the second thing you can do is remove the systemic causes of change failure. You can find opportunities to train people, refine processes, or deploy technology to eliminate the systemic causes of change failure. For example, if the model reveals that the change failure rates are 250% higher for assignment groups that make fewer than a certain number of changes every month, when the change requires downtime, then your action would be to select and train individuals within that assignment group on change implementation best practices, and then ensure that these individuals are assigned to change implementations in the future. So machine learning models can point you in the right direction and tell you where to look, but to achieve true change success, you need a comprehensive set of analytic capabilities that give you both tactical and strategic insight. So these analytical capabilities include, firstly, visibility, also known as descriptive analytics. So what is going on in your change processes and which areas need attention. For example, what is my change failure rate by CI type, change type, and assignment group? How are these trending? Are there any trends that may require intervention? Secondly, investigation. Also known as diagnostic analytics, if you follow the Gartner framework. So what are the possible reasons to explain KPI trends? For example, is the change failure rate trending upward because of an update to the group assignment process? Have there been updates to CIs associated with these changes? The third capability would be correlation. So what are the hidden relationships across data silos that could explain the KPI trends? For example, is change failure rate trending upward because of new test coverage or effectiveness? And finally, prediction. What's the likelihood that an individual change is going to cause an outage? So let's start with a relatively simple example of visibility. So like I mentioned before, according to a recent Gartner study, over 40% of major incidents are caused by people and process around change activity. One example of gaining visibility into people and process would be to calculate the change credit score of a team. So this concept is patterned after the FICO credit score, and so the change credit score is an index that quantifies the trustworthiness of a team to safely release changes into production without adverse customer impact. A change credit score index allows you to reward well-rounded change management performance by automatically approving changes requested by teams with an excellent track record. And there are many ways to calculate change credit score. One of the most basic ways is to score individual best practices and outcomes that you're trying to encourage, weight them by importance, and normalize them, and then add them together into a score. So our customers have used factors like the volume of change-related problems or incidents, number of change-related major incidents, emergency changes that circumvent normal change control processes. And one example of using this methodology would be that of a Fortune 20 healthcare company. A few years ago, they had some major issues with their change management processes, indicated by the fact that around 67% of all all problems were change related. Despite having long weekly CAB meetings around 2.5 hours with more than 30 attendees from across various locations. Does that sound familiar? They used Numerify to implement a change credit score that was calculated weekly per team. Through this methodology, they were able to reduce change-related problems by 64% and reduce the length of CAB meetings to less than 60 minutes weekly. So they accomplished this due to a few key things. The first one is when a team had a good credit score, their changes were approved with minimal scrutiny. This allowed the CAB to concentrate on reviewing change requests from teams that had a less than stellar credit score. And this incentivized teams to take responsibility for the success of their changes, rather than outsource risk management to the CAB. Secondly, if a team had a consistently bad score, representatives from the CAB would help them figure out what they needed to do in order to improve their credit score for the future. For example, they could bring the collective knowledge of the organization to help investigate the root cause of recurring change-related incidents and problems, suggest process improvements to reduce the number of emergency changes, or assign experienced change implementers to mentor less experienced implementers. And finally, because the score is calculated weekly, teams are kept on their toes to maintain their change privileges. In short, the function of the CAB was no longer to just approve or reject changes. Their function was to hold teams accountable for change success and help the teams achieve it. So a more sophisticated machine learning-based approach that I mentioned before would also include the calculated risk of future change as well. And so one question that many of our customers grapple with is, so how can you predict future change failures when you don't really know which changes actually failed in the past? It can be hard to rely on human-entered information in places like your ITSM system to measure change success for a few different reasons. The first one is that incident responders won't always know that the root cause of a change was actually related. So the root cause of an incident was actually change related. And even when they do figure that out, the responders might not explicitly relate the incident to an individual change. And that change-related incidents might be closed without resolution, or change-related incidents might be auto-generated by your monitoring and observability systems, and your incident teams will miss them due to the high signal-to-noise ratio. So the biggest drawback of this comprehensive change-related incident data is that when you have machine learning models that are relying on them for training, you're going to have pretty significant blind spots. So in order to clean this up, you could auto-link changes to incidents, incidents to changes using a similarity score generated by a machine learning algorithm based on factors like the proximity and time. So if the incident occurred soon after a change was deployed, it could be related to the change. Common entities, and so if you're seeing application names or host names or configuration items being mentioned in both the change and the incident, that increases the probability that the two are related. Common keywords, similar to the common entities. Common resources working on and reporting both the change as well as the incident. And finally, cross-references to change and incident numbers in the unstructured text. And so sometimes the incident responder will enter the root cause into the root cause field rather than into the structured field. So once you've improved the training data set for your model, the next thing you would do is use these models to predict the risk of individual changes. And so this is an example of a change risk dashboard that provides overall visibility and prediction of change risk. If you have a change acceptance board or release review board governance process, this dashboard could be used to drive such a meeting. You could also use the outputs of the model to drive automatic change approval and deployment scripts. So on the top, you have high-level performance indicators that show how effective the CAP processes have been and identify areas that need attention. For each change, there's a recommended action based on the change failure probability and flagged risk factors. So this would be used to drive a discussion of whether the change should be accepted or how to mitigate the identified risks. And so an example of the kind of results that you could get out of deploying such a model comes from the example of one of our customers, a top financial services institution. And so starting with what their problem was, they had they generally the change failure rate was pretty good, under 2%. However, they had a hotspot of change failure in their legacy applications with a change failure rate of more than 10%. However, with more than 10,000 changes happening monthly, it was really hard for them to discern the problem patterns. And so the solution was to use machine learning models to analyze the permutations and combinations of more than 100 variables to identify both systemic issues as well as predicting a change failure propensity of an individual change. And the result of that was expected failure reduction of 66% by addressing change risk factors that were identified by the model. And the resulting reduction in priority 1 incidents yielded an annual savings of $1.4 million. So with that, I'd like to transition into a live demo. But before doing that, I'd like to have a quick prayer to the demo gods. I've been using my PowerPoint presentation for the last 30 minutes, so I'm primarily praying right now that my demo environment hasn't timed out and that I don't suffer any kind of internet outage over the next 15 minutes. So let's go ahead and get started. So we're starting here with the IT operations change executive dashboard. We're going to do this demo from the perspective of Sam, who is the VP of IT Ops at Acme Corporation. And so Sam starts his Monday morning with a visit from the owner of the Concord application, which is one of the main applications in Acme Corp. And Sri, the owner of the application, has been complaining that he has quite a few changes that need to happen soon for compliance reasons, but they seem to have been held up. So he asked Sam for help in getting these deployed as soon as possible. So Sam opens the IT Ops Change Exec dashboard to get a handle on what's going on. At the top of the dashboard here are the key metrics that Sam is measuring his team against. You know, you've got your change volume and change lead time. These measure how responsive his teams are to business needs. Change failure and change-related problems, which measure how reliably changes can be made without customer impact. And outage number and duration, which provide a view of overall production health of the applications. So at first glance, there doesn't seem to be any major change-related issues that are applying to all applications. You know, the metrics look fairly stable. And the overall change risk appears to be low. However, looks like we did time out. I'm going to have to re-log in here. Bear with me while I log in again.
While you're doing that, Amit, I'll just go ahead and remind the audience real quick that if you do have a question for Amit, you don't have to wait until we get to the question and answer period. You can go ahead and submit your question at any time. Just use the GoToWebinar control panel.
All right, thank you. And thanks for validating that we haven't lost audio either.
Good.
But yeah, so what I did just before we timed out was I selected the Concord application here, and so the things for the Concord application are looking less good than overall. So the first thing that you notice is that the change failure rate is going to the yellow zone. Second thing that Sam notices is that change lead time has been trending upwards, which validates what the owner of the Concord application had told him. And at the same time, change failure rate is trending upwards as well. And at the same time, there's a good number of high-risk changes coming up. Now, normally, on any given time period, you'd expect maybe 5% or possibly a high of 10% of upcoming changes to have a high failure probability. But this seems to be much higher than that. And so that seems to indicate that overall riskiness for the Concord application has gone up. And so until things are sorted out, the first thing that Sam does is that he asks Pat, Director of Change Management, to look into this and figure out, what he can do to help Sri to deploy more changes. I'm going to refresh the screen here. Great. And so he assigns that out to Pat, and so Pat decides to help Sri by identifying low-risk changes that could be deployed sooner if they're ready to be deployed. In order to accomplish this, he opens this change risk prediction dashboard. And Pat would also runs a release review meeting, and so he would also use this dashboard to run that meeting. At the top are our key performance indicators showing how change teams have performed over the past 30 days. Here you can see under schedule changes at risk, you can see a high-level indicator of the daily change risk across all applications. And when one of the days is selected, you can see all the changes that are scheduled for that day. When you select one of the changes, you can see the top 8 risk factors that the machine learning model has identified that the release review board should pay attention to. So the Numerify change risk machine learning model identifies these risk factors by sifting through the permutations and combinations of various data in your change incident CMDB systems, as well as your upstream development systems and the downstream APM systems. And so Pat first takes a look at the change calendar for the Concord application. And it looks like there's an upcoming change window on the 4th of December that is fairly low risk, doesn't have too many changes already assigned for that day. So that would be a good day. If you wanted to move ready changes for deployment, this would be a good day to move them to. And so the next thing Pat does is he looks through scheduled changes to identify changes that could be moved to December 4th, and depending on the credit score of the team, as well as the overall risk. And so moving to the 11th of December, looks like there's a good number of changes on that day. But there's 2 changes in particular that are low risk that could be good candidates. One is this one. That has been requested by Todd Swanson. And so Todd has a credit score of 240. So if you remember, credit score is measured on a scale from 0 to 850, like your FICO credit score, and 240 is actually not very good. At the same time, there's been a high number of CI alerts on the server that this change would be deployed to, and there's a high number of pre-production defects, as well as a low number of prior changes. And so each one of these is a risk factor on its own. High number of CI alerts indicates that there's been, that there could be something going on with the hardware of the application or software that's deployed on the on that server. High number of pre-production defects is fairly self-explanatory. High number of defects indicates higher level of risk. Prior changes is not very. There's not been a lot of changes deployed, so it's a relatively immature server that we're being deployed to, that we're deploying the change to. But looking at all of these various things, the fact that it's a low impact change, that it doesn't require any downtime, it's coming from a group that has generally it's being deployed by a group that has a low failure rate overall, hasn't been rescheduled very often. So that seems to indicate that, despite these risk factors flagged, it's actually a pretty low risk change. But, it's being requested by Todd, who doesn't have a high credit score, and so Pat decides that he probably needs a little bit more scrutiny before automatically approving this change. Second change that he looks into is requested by Mary Stevenson, who has a very high credit score. It's pretty stellar, 750. And so this one gets automatically approved for deployment. And so looking at the high number of CI alerts, Pat decides to take a look to see whether the high number of CI alerts is actually change related, whether it's related to a past change failure. And so in order to do that, she goes to the application change impact dashboard here. So at the top of the dashboard are some of the same metrics that Sam used to measure the change effectiveness of his teams. And just below it are recent changes as well as their outcomes. And at the bottom are key measures that can help correlate a change and its impact. So while correlation does not always mean causation, it can help Pat formulate hypotheses to validate. And so the first thing that she notices is that there's been a spike in the number of user incidents between the 22nd and the 23rd of November. And that corresponds with a spike in the number of slow transactions, as well as a spike in the number of alerts in the database tier. So she looks to see, whether there was any change that occurred between the 22nd and the 23rd that might explain this. So in order to do that, she's going to sort by date, and then look to see if there was anything changed on the 23rd. And so it looks like there was only one change that occurred on the Concurrent app on the 23rd, and that was a MySQL upgrade for version 6.5.6 to 5.7. And so this looks like a likely candidate to explain the spike in database tier alerts, as well as the spike in slow transactions. It's not uncommon when you upgrade a database to that some queries will run slower if you don't change how they're tuned. And so Pat contracts Carol. Carol is the assignment manager of the group responsible for the change, to look at whether this could be the cause. And so Carol first checks to see if there are any patterns in the recent user incident data and problem data that could indicate slowness in DB queries, and she finds that the production and development and test environments are out of sync. So they upgraded the production environment, but did not upgrade the server in the test environment. And so as a result, there were some changes. There were some tests that didn't run correctly, and so they were not able to catch this. And so the application development manager for Concord estimates that it would take them about 2 weeks to upgrade the test database, run regression tests, and develop the fixes needed. And the next thing that Pat decides to investigate is the credit score for Todd Swanson's team. So again, as a reminder, the change credit score was pretty low for Todd, and so she decides to take a look at what might be driving that. And so looking at Todd's credit score, it seems like the low score is driven by a few different things. The first one is the failure deduction. So this is driven by a fairly high change failure rate of 7%. Probably not much that Todd can do about that, because this is just indicative of past experience that's only going to improve over time. But the things that Todd can improve in his team, so no plan deduction. So the change plan was not documented or was too short. So it's possible that a more comprehensive change plan might have outlined the importance of keeping your test and production environments in sync, and how to monitor the success or failure of changes, so that issues can be detected by change teams before customers report them. And the second one is overdue tasks. There's 100 points deducted there. And so this indicates that change tasks were not completed or documented as completed in the change tracking system. And so this makes it hard to maintain the integrity and auditability of change processes. And so Pat assigns an expert to help Todd get his scores up. So with that, let's go back to the presentation. So that's the end of the prepared part of this presentation. In conclusion, here are a few takeaways. So the first one is that even in the era of DevOps, without very high levels of automation, human oversight on change processes is probably not going away anytime soon. For example, to improve change lead times and change success times, DeVerify customers have used AI techniques to elevate the function of the ITIL cap to hold teams accountable for success. help mitigate change risk, and help teams adopt the best practices that will lead to better outcomes. At the same time, clear communication on change processes is vital for change success. So make sure that your teams know what they're being measured on so that they can navigate their way to getting changes out faster and more successfully. And finally, automating change management is a journey. And many of our customers have found that the road to automation starts with business analytics and AI for decision support. And so with that, I'd like to hand it over back to you for questions.
All right, great. We have gotten some questions in, actually lots of questions in, but there's plenty of time for questions. If you do have a question for Amit, please go ahead and use your GoToWebinar control panel. Let's go ahead and get started with the first one here. Let's see, if you had to recommend one place to get started on improving change success, what would that be?
Well, that's a great question, and we get that a lot. If we had to start with one place to get started on change success, in our experience, usually starting with holding your teams accountable is usually a good place to start. And so a lot of our customers get started with change credit score before moving on to operationalizing machine learning models, right, to predict the risk of individual changes. And the reasons for that are fairly, they're obvious, but they're important. First one is that, like Gartner, I mentioned this a few times, but as Gartner has indicated, 40% of change failures are related to people and process factors, not necessarily technical factors. And so the best way to solve people and process factors comes down to defining the right processes and behaviors and then measuring teams against it. And so you can get some pretty quick wins by driving change management processes around change credit scores. So that, if I had to pick one place to get started, that would probably be it.
All right, great. Next question. How is the risk tied back to governance to avoid the risk early on in the software development lifecycle?
That's a great question. So risk being tied back to governance as it relates to the to early in the life cycle. So I think what that comes down to would be correlating data from your development processes. I think the first part of this, the left-hand screen, left-hand part of the slides here, to change failure, and using that to predict change failure. Basically, what we've found in the various customer deployments that we've done so far is that the more data you feed a change risk prediction model or any machine learning model in general, the higher the probability that you're going to get meaningful results out of it. And the one that we found that seems to have some of the biggest bang would be using data from systems like Jira in your development processes to predict future change. Future change success. And so if you are finding things like high number of pre-production defects above a certain threshold, seems to be indicative of change failure. If you're having issues like, build quality seems to be an indicator of change failure, or the number of commits, how often someone is committing their code. Are they doing it daily? Are they doing it every few days? We've found generally that if folks are integrating their code on a daily basis, that leads to higher change success. So finding and quantifying things like that can then help you feed that information, to the upstream parts of the development cycle, so that you have the justification to invest in the things needed to, improve code quality, whether it's automation, higher test coverage, or the quality of the code itself. Invest in training your teams on branch coverage, code coverage, things like that. So that's how we've seen our customers typically tie the results of a change risk prediction model to the governance of development.
All right, great. Next question here. How is the explainability of deployed models being handled?
Explainability of deployed models being handled. So I'm going to cut back over to the demo environment to answer that one. So really the explainability comes down to identifying the risk factors up front, and then being able to figure out, not just why a change was scored a certain way, but what the factors were. So that's really in this case, it's these 8 things here that the model had flagged. And so what we've got here are red, yellow, and green indicators that are based on thresholds or values. And so, for example, here, number of CI alerts, CI prior changes, you can basically tell a story around why a risk is high, medium, or low risk based on where these factors are and what thresholds were set. So that's how we've encountered explainability, or how we've used explainability and deployed it. So yeah, just knowing that a risk is it's high risk isn't particularly helpful, especially if you don't know what you're supposed to do about it. And so, yeah, explainability is extremely important. But typically, what we do is we take these, we identify what the higher risk factors are, what the thresholds are that indicate that that particular variable is risky. And also, the other thing that we do, let me see if I can open it up here, is we've got so in order to figure out what risk factors are significant, we also look at risk factor analysis to see to explain why those thresholds are where they are. So you can look to see failure rate by prior CI changes. So this is basically telling you, for example, in this case, that if you had less than 5 changes, then the change on that particular configuration item, then that seems to indicate a higher change failure rate. And so these are the other things you can use to explain the output of your change risk prediction model.
Okay. All right. Great. Quick time check. We're about 7 minutes to the top of the hour, so I think we can do 1 or 2 more questions here. Next question. Notice you have an indication of availability. Do you have any feature integrating with SRE practice, also displaying service level indicator and service level objective status?
Yeah. So I guess these different things, these metrics, typically come from different systems. But so yeah, we have pre-built integrations with monitoring and observability systems for availability. So for example, App Dynamics, New Relic on the application availability side. Those are just examples. Dynatrace is another one that we pre-integrate with. Yeah, so that's where we get the data for availability. In terms of site reliability engineering best practice, I'm not quite sure I understood the rest of that question. Could you repeat it, please?
Yeah, sure. Let me get back to it here. Let's see. Notice you have indication of availability. Do you have any feature integrating with SRE practice, also displaying service level indicator and service level objective status?
All right. Yeah. So service level indicator and objective status. So yeah, the service level indicators, I think we have generally found that you have to digitize your SLAs in order to be able to measure availability or outage, a total indication of degradation, things of that nature against what your service level objectives were. And it's not, you usually aren't going to find, you might find something like that in your observability systems. You might not. If you don't, we actually do have the ability to digitize your SLA contracts with your various teams or vendors and enter them into our product. Yes.
Okay, all right, great. Let's do one more question and then we'll go ahead and close out the question and answer period. Let's see, can we talk about integration ease of these IT ops dashboard with ops and change management tools? So,
Yeah, that's a great question. And so, the part of our value proposition is our ability, is the fact that we have pre-integrated with all of these various tools. And so every single one of these systems, most of them anyway, may make the data from within the system available via APIs. And so we have a REST API-based integration with ServiceNow, BMC, for example, on the ITSM side. Same with AppDynamics, New Relic, Splunk, Dynatrace, and all of these systems have APIs. And so we have pre-built integrations into these systems that utilize those APIs. But that's really only the first step of the process. The second step of the process is to make sense of the data once it comes in. And so we have a proprietary model that models all of IT operations so that you can normalize across all these various sources. But it's not uncommon for one of our customers to have multiple monitoring and observability systems across all their teams, right? Or multiple versions of ServiceNow or BMC or maybe and ServiceNow all together within the same environment. And so we have a model, a pre-built data model that basically normalizes across all these various data sources and puts them into into a star schema that basically allows you to slice and dice and query the data. But that's really what our secret sauce is in order to be able to quickly get up and running.
all right, great. Well, we are about 3 minutes to the top of the hour, so I do have to close out the question and answer period. If we didn't get to your question, I apologize, but please know that Amit and Numerify will be getting a copy of all of the questions that came in, so I'm sure they'll be more than happy to follow up with you offline. Also want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. Following today's webinar, we are going to be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be on the DevOps.com website, so you can always find it there. You can just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, at the top of the hour, I did mention that we would be doing a drawing for 3 $50 Amazon gift cards. So without further ado, let's go ahead and do that. Today's winners are Heidi R. Congratulations, Heidi. Our second winner today is Jamie S. Congratulations, Jamie. And our final winner today is Oscar L. Congratulations, Oscar. And also want to thank Amit for such a great presentation today. Thank you so much. Great stuff. And judging from the number of questions we got in, I know the audience got a lot out of it as well.
Oh, thank you very much, Charlene. Thanks to DevOps.com for the opportunity. And yeah, we look forward to working with you in the future, and we look forward to hopefully interacting with more of you in the future.
All right,
the attendees.
excellent. Excellent, excellent. Well, also, I want to thank the attendees also for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and stay safe.